Welcome to our exploration of MLOps in 2025, where we focus on turning experimental notebooks into production-ready, scalable AI systems that drive real business value. In this presentation, we'll walk through how teams move from prototypes to repeatable pipelines, the tooling landscape, and the practices that help organizations get reliable, measurable outcomes from machine learning at scale. In this chapter, we trace how MLOps rose to tame the chaos of ad hoc ML development, turning fragmented workflows into streamlined, automated pipelines. We'll look at the practical problems that forced this shift and how early patterns evolved into the discipline we recognize today, setting the stage for operational, repeatable machine learning in production environments. MLOps matters because it converts model experiments into dependable business outcomes, often improving accuracy and reliability dramatically while cutting lifecycle costs through automation. Organizations that adopt MLOps don't just ship models faster, they create consistent, cost-effective AI systems that scale, reduce risk, and deliver predictable results across diverse production environments and teams. The story of MLOps began by borrowing DevOps lessons and applying them to machine learning, introducing version control for models and data, containerization for reproducibility, and automated deployment pipelines. These early frameworks tackled complex data dependencies, scalability bottlenecks, model drift, and cross-team collaboration, laying the groundwork for modern production ML practices. Through 2020, the ecosystem matured as major cloud platforms launched enterprise-grade ML services, data versioning and feature management tools improved collaboration, and CI/CD principles were applied to model delivery. These advancements created scalable pipelines, better reproducibility, and faster iteration cycles, enabling teams to move from experimental code to robust production systems. The MLOps timeline shows a clear progression. Foundations like Kubeflow and MLflow in 2018, cloud expansion through 2019-2020, the generative AI surge around 2023, and the rise of hyper-automation by 2025. Each milestone introduced new capabilities and challenges, shaping how teams operate, monitor, and scale machine learning across organizations. As generative AI and real-time demands converge with MLOps, we're seeing a major shift in how systems are built, deployed, and monitored. This chapter explores the implications of large foundation models, edge deployment, and the rising need for instant observability and scalable infrastructure to meet modern performance and latency expectations. The generative AI revolution introduced scale and observability challenges of a new order, fine-tuning and serving billion-parameter models, plus the urgent need for real-time monitoring to catch drift, hallucinations, and performance degradation. These pressures pushed MLOps teams to develop new infrastructure patterns and monitoring practices to keep models reliable in production. Edge computing and hybrid cloud strategies are making AI ubiquitous, from giant training clusters to tiny devices running inference. Deployments at the edge enable real-time decisions in healthcare, personalized retail experiences, predictive maintenance in factories, and privacy-preserving low-latency processing, expanding where and how intelligent systems deliver value. Regulation and ethics have become core components of MLOps, not afterthoughts. Global frameworks like the EU AI Act enforce governance and accountability, while pipelines increasingly embed bias detection, fairness metrics, and audit trails to ensure responsible AI practices throughout the model lifecycle. Responsible AI is now a built-in requirement for production systems. Scaling AI requires balancing centralized cloud power with distributed edge intelligence. The cloud delivers massive compute, centralized data lakes, and global training capacities, while the edge enables local inference, low-latency responses, and privacy-preserving processing where data is created, allowing organizations to deploy AI across diverse operational contexts. Understanding your place on the MLOps maturity curve is the first step toward building world-class AI systems. And this chapter walks through how teams evolve from manual workflows to highly automated, self-learning pipelines. Knowing where you stand helps prioritize investments in tooling, processes, and organizational alignment to accelerate progress. Many organizations start with manual workflows where data scientists prepare datasets locally, train models on individual machines, and hand off work to engineering for deployment. These ad hoc processes lead to infrequent releases and minimal production monitoring, and while common, they also signal the need to rapidly evolve toward automation to scale reliably. The first step up is automating training pipelines so that fresh data triggers continuous retraining, modular code and shared feature stores improve consistency, and teams can iterate on weekly cadences instead of quarterly. This level reduces manual toil, speeds experimentation, and sets a foundation for more advanced CI/CD and operational practices. At this stage, teams begin running multiple automated pipelines in parallel with sophisticated orchestration across environments, centralized model registries with version control, and comprehensive monitoring and alerting. Operational practices include retraining on drift, A/B testing, canary releases, and automated rollback, enabling continuous delivery of reliable models at scale. As organizations mature, the MLOps maturity pyramid organizes progress from manual practices to automated training and finally to full CI/CD at enterprise scale. Climbing this pyramid means adopting shared workflows, repeatable pipelines, and governance that support frequent, safe model updates across production environments. Now we turn to tooling. The 2025 landscape blends cloud platforms, open source, and specialized tools that together enable modern MLOps. Choosing the right mix depends on scale, governance needs, and whether you prioritize managed services, hybrid deployment, or cutting-edge foundation model operations, so we'll highlight key players and capabilities. Major cloud providers offer integrated, enterprise-grade MLOps experiences in 2025. Services that enable one-click deployment, real-time monitoring, multi-model endpoints, marketplace integrations, and responsible AI dashboards, reducing operational friction and helping teams get production value faster while leveraging managed infrastructure. Open source and specialized tools remain critical for flexibility and portability, powering experiment tracking, pipelines, and data versioning. Tools like MLflow, Kubeflow, iScan, and DVC provide the building blocks for reproducibility and scalable workflows, allowing teams to integrate best-of-breed components into their MLOps stacks. New tools focused on foundation models and LLM operations are emerging to address layer-level monitoring, metadata tracking for distributed training, and streamlined experiment orchestration on Kubernetes. These platforms help teams manage the unique requirements of large models and collaborative research to production workflows at scale. The MLOps ecosystem map highlights a rich, interconnected landscape where platforms and tools serve specialized needs while integrating with broader systems. Success comes from composing the right combination of services and tooling for your use case, balancing manageability, cost, and operational control. In this chapter, we cover best practices for building smarter MLOps in 2025, focusing on patterns used by leading AI teams to deliver reliable, scalable, and ethical systems. These practices blend collaboration, automation, observability, governance, and resource efficiency to unlock sustained production value from machine learning. Breaking down silos is essential. Unify data scientists, ML engineers, and DevOps teams around shared tools, vocabularies, and integrated platforms while automating repetitive tasks end-to-end. This combination of collaboration and automation creates the foundation for faster, more reliable ML delivery and clearer ownership across the lifecycle. Continuous monitoring and observability are vital to catch problems early. implement real-time drift detection, bias monitoring across demographic groups, and maintain model registries with comprehensive metadata. These practices preserve performance and fairness in production and provide the auditability required for governance and compliance. Good governance embeds fairness and regulatory readiness into pipelines, with automated bias checks in training data, fairness metrics during evaluation, demographic parity monitoring, and explainability for high-stakes decisions. Transparent audit trails, EU AI Act compliance workflows, and versioned model cards support accountability and reproducibility. Scalability and hybrid deployment strategies enable elastic growth. Adopt cloud-native architectures using containers and serverless functions, deploy lightweight models to edge devices for minimal latency, and optimize costs with multi-model endpoints, serverless GPUs, and spot instances to reduce infrastructure spend significantly. The future of MLOps brings hyper-automation and sustainable AI together, creating autonomous ML systems that adapt while prioritizing environmental responsibility. This chapter explores how self-learning pipelines and green practices reshape the way organizations build and run AI at scale, blending efficiency with ethics. Hyper-automation envisions self-learning pipelines that detect drift and retrain autonomously, validate and auto-deploy models, and continuously adapt to changing data patterns. The goal is ML systems that learn and improve with minimal human intervention while preserving reliability through robust validation and observability. Sustainability and responsible scaling are now central to MLOps, with energy-efficient techniques like model compression, quantization, and carbon-aware scheduling reducing compute footprints. Efficient training algorithms and renewable-powered data centers make green AI a first-class concern rather than an afterthought for production workflows. To wrap up, MLOps is the backbone of AI innovation, translating theory into production realities that deliver measurable business value. Mastering these practices, tools, and mindsets is critical to unlock AI's full potential, and your journey starts now as you build the systems and processes that will power the next generation of intelligent applications.